What's going on, guys? Let's look at this problem right here. Here this question is asking, consider the following microops: A R2 R1 and not A and B, R3 to R1, R3 to R2. Now let's see how to design this one. Here it's asking, design the hardware for implementing these microops using a single bus and registers with 3 state outputs with output enabled signals. Now let's see how the 3-state output is going to look like. But before that, let's look at this one. This design. This part is input. A is input. And this one is control input. Control input. And this one is y is equal to A, and if C is equal to 1, then it's high impedance. Y is equal to A if C is equal to 1, but high impedance if C is equal to 0. High impedance if C is equal to 0. Okay, let's go ahead and continue. Here we asked to design a 3-state buffer, 3-state buffer. Now let's see how the design is going to look like. Here R is, let's notice one more thing. Let's note one more thing. That's R is read enable, and double G is write enable. Okay, let's go ahead and design the hardware. Register R1. Here we will have read enable, write enable. R2 read enable, write enable, and R3 read enable, write enable. All of them are connected to this. And here we are going to connect everything to a decoder. Let's put the decoder somewhere here. Okay, this is a 2x4 decoder. Here we will have S1, S0, and E. And here we will have 0, 1, 2, 3. And this one, here we have 3 things, and also we will have a D0 connected here. D0 connected like this. Now this one, all of these things, the first one connected to the 0, the second one connected to 1, and third one connected to 2, and the fourth one connected to 3. And for this decoder, the input is going to be an 2 OR gates. 2 OR gates, and also this first OR gate connected to S1, the second OR gate connected to S0, and the enable E connected to enable. E is enable. Okay, now here they have, in the question they have mentioned this is not A and B. So not A and B, and also we have A. So this one, this is A, and here we put a not. This is A connected right here. This is not A and B. Okay, not A and B. And here we have another thing that is connected right here, and this one is connected with this one. Okay. Now the next thing is we have to connect everything with the register. I make it a different color so you can see it clearly. So from the first read, we will have a connection to this line right here, and also from the second write we will have a connection with this one again, and from the read of the first one, let's use a different color, we will have a connection right here, and that's it. That's the design of the given expression. Hardware implementation of the given expression, and this line is the common bus line. Common bus line, and also I forgot to mention something. This here for the second one, the read will be connected to not A and B, and here for the third one the write will be connected to not A and B, and for this one here A, here not A and B. That is the design for this given expression, hardware implementation of the given expression. I hope you guys find this video helpful, and I'm going to go more detail of these topics on upcoming videos. I hope you guys watch that too, and don't forget to subscribe. See you next time.